Okay, so what if I told you there could be a world out there made not of rock and water, but of pure, glittering diamond? It sounds like something straight out of science fiction, right? Well, today, we're going to dive into the very real science behind one of astronomy's most dazzling ideas, carbon planets.
So, could a planet really be made of diamond? I mean, a world literally glittering with treasure. It's such a mind-boggling idea. Could a planet's entire geology actually be based on pure crystallized carbon instead of, the familiar rock and soil we have here on Earth? Let's dig in and find out.
All right, so first things first, we need to understand the core concept here, the carbon planet. And no, this isn't just a fantasy, it's a real theoretical type of exoplanet that astronomers think can form, but only under some very specific conditions. Basically, it has to be in a solar system that's super rich in carbon and pretty poor in oxygen.
Yeah, you can think of it like a cosmic recipe. It all comes down to the star's carbon-to-oxygen ratio. Seriously, just like baking a cake, the ingredients you start with totally determine what you end up with. You see, stars and their planets form from the same giant cloud of gas and dust. If that cloud has a ton of carbon, well, you're on your way to getting carbon planets. Our own sun, on the other hand, has a lower carbon-to-oxygen ratio, and that's exactly why we live on a silicate-based world like Earth.
Okay, so theory is one thing, but do we have any actual real-world candidates for this? Oh, you bet we do. Let's introduce the prime suspect in our Diamond World investigation, a fascinating exoplanet named 55 Cancri E.
This planet has seriously captured everyone's imagination. Scientists, the public, you name it. As this Reddit user points out, it's kind of been the poster child for the whole carbon planet theory for a while now. The basic idea is that with so much carbon floating around in its system, the insane pressure deep inside the planet could have literally squeezed it into vast quantities of diamond.
And the stats on 55 Cancri E are just staggering. For starters, it's a super Earth, weighing in at about 8 times the mass of our planet. But check this out, its orbit period, it whips around its star, completing a full year in just 18 hours. Can you imagine? That crazy proximity means it is blisteringly hot. I mean, a world totally, utterly unlike our own.
And of course, we have to talk about the price tag. I mean, come on. Based on the theory that a third of this planet's mass could be diamond, its estimated worth is, well, it's 26 nonulin dollars. That is a 26 followed by 30 zeros. It's a number so huge it's almost meaningless, right? But it for sure adds a major wow factor to the story.
So we've got this incredible theory, and we have our prime suspect. But how in the world do you actually confirm what a planet 40 light-years away is made of? Well, that brings us to the next chapter in our investigation.
Enter the hero of our story, the most powerful space telescope ever built, the James Webb. Its sensitivity is so incredible, it can do something that still blows my mind. It can actually analyze the light from a star as it filters through the atmosphere of a distant exoplanet. It's like cosmic detective work. By decoding that light, scientists can spot the chemical fingerprints of different gases, and that gives us major clues about what the planet itself is made of.
So, the JWST observations basically set up this fascinating scientific showdown. There were 2 competing theories for what was going on with 55 Cancri E. Theory number 1, it has a thick, soupy atmosphere, rich with stuff like water or carbon dioxide. Or, theory number 2, it has a thin, really exotic atmosphere that's literally made of vaporized rock, a mineral atmosphere. Whichever it was, the answer would tell us a whole lot about the planet hiding underneath.
Now, while the James Webb was peering deep into space, another team of scientists was looking inward. They were trying to do something just as amazing, recreate the extreme conditions of a carbon planet right here in a lab on Earth. So let's see how they put this whole theory to the test.
And the challenge here was immense. Researchers had this hypothesis, right? They thought, okay, if you take the right ingredients, in this case silicon carbide and water, and you subject them to the absolutely crushing pressures and intense heat you'd find deep inside one of these planets, you should be able to create diamond. So, how'd they do it? Well, here's the play-by-play. First, they took some silicon carbide, that's a carbon-rich mineral, and dunked it in water. Then, they put that little sample inside what's called a diamond anvil cell, which is basically a device that uses 2 actual diamonds to generate unbelievable pressure. While they were squeezing it, they blasted it with a laser to heat it up like crazy. And the result? It worked. The silicon carbide and water reacted to form exactly what they predicted, diamond and silica. This was a total game changer. It was the first experimental proof that this weird, exotic chemistry could actually happen.
Okay, so we've now established that diamond worlds are scientifically plausible. They could be out there. But that just brings up another, even deeper question. Could life, find a way on a planet made of the hardest substance in the universe?
Well, the scientific consensus is probably not, and here's why. A mantle made of diamond would be incredibly rigid. It would be too hard for geological activity like plate tectonics and volcanism. Here on Earth, those processes are absolutely vital. They're like the planet's thermostat, recycling materials and regulating our atmosphere over millions of years. If you don't have that, a planet's climate would likely just be completely unstable and super hostile to life. It's a really fascinating reminder that for a planet to be habitable, it needs this delicate, dynamic balance.
Exploring wild worlds like these also forces us to rethink what actually makes a planet habitable in the first place. For instance, a lot of people think a magnetic field is absolutely essential, but the reality is a little more complicated than that. It turns out a planet's sheer mass and a really thick atmosphere can do a lot of the heavy lifting when it comes to protection. Just look at Venus. It has no magnetic field to speak of, but its immense gravity holds on to an atmosphere that's 90 times denser than Earth's.
So this whole journey into carbon planets is way more than just a fun curiosity. It's actually pushing the boundaries of what we thought we knew about how planets form. It's opening up a whole new frontier for research, and that's really exciting.
And you can see that commitment to understanding these exotic worlds everywhere. We're not just relying on bigger and better telescopes anymore. Advanced facilities like the Fair Particle Accelerator over in Germany are literally being built to recreate the insane pressures you'd find deep inside a planet. This is going to let us test our wildest theories with incredible accuracy without even leaving Earth.
Honestly, we have only just scratched the surface here. Think about it. Carbon planets, once just a purely theoretical idea, are now a real, tangible area of research. It just makes you wonder, doesn't it? If worlds made of solid diamond are out there, what other cosmic marvels are waiting to be found? What other strange new worlds are we right on the verge of discovering? It really seems like the universe is always ready to surprise us.